Hi guys, in this video tutorial, I'm going to guide you with another type of chi-square test, namely goodness of fit test. In general, there are two types of chi-square tests, namely independence test. We have discussed about this test in the previous video tutorial. And the second type of chi-square test is goodness of fit test, which will be discussed in this lesson. Now let's have a look at what is the application of goodness of fit test. Goodness of fit test is a non-parametric test that is used to determine if the distribution of the observed outcomes of a sample supports a hypothesized population distribution. This can be reflected into the hypothesis, where the null hypothesis of goodness of fit test should state that the observed results fits into a specified distribution pattern, or in other words, there is no difference between the observed results and the specified distribution pattern. On the other hand, the alternative hypothesis of GOF should state that the observed results does not fit into a specified distribution pattern, or there is a difference between the observed results and the specified distribution pattern. Now let's have a look at what kind of scenarios that require the use of goodness of fit test. The first example is given here. A factory manager needs to understand how many products are defective versus how many are produced. In this scenario, we can see that there are two types of samples that need to be compared. The first one is the actual number of defective products, and the second one is the estimated number of the defective products. Hence, the null hypothesis can be written as the number of defective products fits into the expectations, and the alternative hypothesis can be written as the number of defective products does not fit into the expectations. The second example is given here. A statistician wants to know whether the distribution of the number of pets per house in Johor is different from that of per house in Malaysia. You can see clearly that there are two samples. The first one refers to Johor sample, and the second one is the Malaysia sample, which is also known as the hypothesized distribution. So the null hypothesis can be written as the number of pets per house in Johor fits into that of the Malaysia's distribution, and the alternative hypothesis can be written as the number of pets per house in Johor does not fit into that of the Malaysia's distribution. Now let's have a look at what are the steps of goodness of fit test. Basically, there is no much difference between independence test and goodness of fit test in terms of their steps, but perhaps you need to take note on few things that might slightly differ. The first step is to set the hypothesis, both null and alternative hypothesis, followed by the second step, that is to compute chi-square statistics. As you can see, the formula of the chi-square is similar with that in the independence test, where O stands for the observed frequency and E represents the expected frequency. And also you have to create a contingency table in order to solve for the chi-square value. Additionally, we need to identify the observed and expected data from the equation because sometimes it might not be given directly. The third step is to make a decision by comparing the computed chi-square value from step 2 and the tabulated chi-square value from the table. The rule of thumb is that we reject the null hypothesis if the value of chi-square statistics or calculated chi-square is more than or equal to the chi-square table, and we accept the null hypothesis if it is the other way around. The degree of freedom is slightly different. Is given by k minus 1 for this test, and k represents the number of level of the categorical variable. The final step is to make a conclusion. We have to state the accepted hypothesis in detail, and we have to be specific with the variables of the problem analyzed. Now let's have a look at one example of non-parametric equation that requires the use of goodness of fit test. Suppose you are a demographer conducting research on the number of children preferred by American couples. Realizing that attitudes may have changed over the past 5 years, you conduct a national study of 600 couples. The distributions for 2015 and 2020 are presented here. Calculate the value of chi-square by using the goodness of fit test and test the null hypothesis at alpha equal to 0.05 that the preferred number of children has not changed from 2015 to 2020. These are the data given in the equation, 2015 and 2020 data. Before we go into the solution, let us analyze the data briefly. Since it is not given in the equation which set of data is the observed data and which is the expected data, so we have to decide and identify by ourselves. Basically, in this equation, we need to compare these two sets of data and to see whether or not the current data, that is 2020 data, is equal to 2015 data or not. So apparently, we are observing the 2020 data and we expect it to be the same as the 2015 data. So the rule of thumb, if we are given two sets of data that are in different years, the later or the current data normally represents the data that needs to be observed, whilst the previous data represents the benchmark of comparison, hence it is the expected data. So in this equation, 2015 data represents the expected data and 2020 data represents the observed data. The second thing that we have to identify is the value of k. The value of k represents the number of level of the categorical variable, which is preferred number of children in this problem. So you can see that there are 3 levels, namely 0, 1 or 2, and 3 or 4. So the value of k is given as 3. Now let's have a look at the solution for this problem. The first step is to set the hypothesis, both null and alternative hypothesis. The null hypothesis can be written as the 2020 data fits into the 2015 data, or there is no difference between the 2020 data and the 2015 data. On the other hand, the alternative hypothesis can be written as the 2020 data does not fit into the 2015 data, or there is a difference between the 2020 data and the 2015 data. In the second step, we have to compute the chi-square statistics. This is the formula of chi-square, and in order to find what is the chi-square value, we have to create a contingency table. This is the original data given in the equation, and here we have labeled the 2015 data as the expected data and 2020 data as the observed data. The contingency table for goodness of fit test is actually much simpler than that in the independence test. So here, the categorical variable is the preferred number of children, and there are 3 levels of the preferred number of children, 0, 1 or 2, and 3 or 4. What we have to find next is the value of O minus E squared and O minus E squared divided by E. So that are the values solved for every level for the categorical variable. And finally, we have to find what is the summation of the O minus E squared divided by E, where the final value is given as 16.4. And that represents the calculated chi-square or chi-square statistics. In the third step, we have to make a decision by comparing the computed chi-square value from step 2 and the tabulated chi-square value from the table. This is the chi-square table. The degree of freedom is given as 3 minus 1, that is equal to 2. The alpha value, as given in the equation, is 0.05, so that represents the value of P in the table. So the value of tabulated chi-square is equal to 5.991. Comparing the value of chi-square statistics as obtained from step 2, which is equal to 16.4, we found out that the chi-square statistics is more than the chi-square table. Hence, the decision for this problem is to reject the null hypothesis or to accept the alternative hypothesis. In the fourth step, we have to make a conclusion, whereby we have to state the accepted hypothesis in detail. Since we accept the alternative hypothesis in step 3, we can conclude that at alpha equal to 0.05, the 2020 data does not fit into the 2015 data, or we can also say at alpha equal to 0.05, there is a difference between the 2020 data and the 2015 data. So that wraps up the 4 steps that we need to perform in order to analyze a non-parametric question using goodness of fit test. So that's all for now. Thank you very much for watching. For more video tutorials on statistics, please subscribe to No Statistics No Talk on YouTube. Till then, have a nice day.